In this video, we are going to take paper 3 practical section over there, 9702 as the main paper, which is a practical paper over there, and you will have to perform this paper in the uh, laboratory over there. And this paper tests about your ability to do physics, not just to remember it. It checks that how you plan the experiment, means it will check about plan of experiment, plan an experiment over there. After that, it also checks how accurate measurements will be taken, make accurate measurements, accurate measurements. And I will also say that it is going towards record the data, like to record and process the data. Record and process the data over there. Process the data over there. And I will also say that it will be going to deal with at number 4, I will say plot and intercept the graphs. Plot and intercept the graphs. Intercept the graphs over there. And also we'll talk the identification in the last section of question number 2 over there. It will go for identify and reduce the errors. Identify and reduce the errors, give the possible advantages and disadvantages like that, and identify and reduce errors over there. If I talk, then I will say this practical paper represents the hands-on side of the syllabus over there, developing the habit of precision in real scientist use over there. And this paper is of 2 hours paper. 2 hours is the time duration of this paper. And there are total 40 marks are available. That is the max marks over there. And I will also say that usually there are 2 questions are available. And it can be 2020, it can be 1525 will be over there. Your question number 1, if I talk about it, then it is about data collection, data analysis, data collection. It is about data analysis. It is about graph plotting over there, means you will have to get the experimental values, graph plotting. And graph plotting is available for question number 1. How you will do all of this? You will get the data collection from the given experiment over there. Then you will analyze. Then you will draw a graph over there. That will be related to question number 1. And question number 2 is about that is a shorter practical over there. Shorter practical, in which mostly we can say planning and reasoning. Practical, in which we can say we will have to discuss about planning and reasoning over there. Planning and reasoning, to talk about reasoning will be available over there for details section over there. Now I'm going toward detailed breakdown over there, and then I am saying question number 1, which I am highlighting over here. Question number 1 is this is you can say man experiment which you will have to perform in the laboratory. Question number 1, man experiment, which you will have to perform in detail. The apparatus will be provided or already provided in your examination hall section over there. And this is the core part of the paper. It is hand-on investigation with clear aim, like to investigate the relationship between X and Y, like you are being provided some quantity X and Y relationship. You will have to investigate between two variables relationship, X and Y relationship. We will have to investigate the relationship between two variables like X and Y over there. And basically, for doing this whole purpose, you will have to break down this experiment. First of all, the main section is understanding the M over there. Understanding the M of this experiment, where we can say you will usually will be given the relationship of the form like it can be given the relationship in the form of y is equal to mx plus c. Relationship will be provided in this format, or it will be having some exponential form where you can say that y is equal to kx power n, and then you take the logarithm on both sides in the form of natural logarithm ln y is equal to, if I take this power in the start, then I'm saying nx n ln x plus ln k over there can be taken. These two main formats of relationships will be given in the question. Only one will be given depending upon the scenario which he wants to examine over there. And exam which will be provided to you wants you to measure the right quantities. It will be requiring over there for understanding this M, that which equation, first of all, identify which equation is being used over there. Then I will say number one, measure the right quantities, measure the right quantities. Over there, that is the first man step. Then process the data to make it linear. Then process the data to make it linear over there. And I can also say it, if it is needed, then you can make it linear. Otherwise, no need to do that. And then the third step is plot the graph between the variables over there. Use the graph to determine the constants, gradients, and intercepts. At number 4, I'm adding the last step over there, which I am saying here, use the graph which you have plotted, use the graph to determine, to find the constants, and also I will say the gradients and intercepts, and gradients and intercepts over there. So this is our main experiment, understanding M over there, for showing the whole relationship over there. That when you have already got the whole understanding of that experiment, then you will move towards recording the data over there, recording the results over there like that. So first of all, after the understanding of M, then you will move towards recording results and data table over there, recording results, where we can also say that it can be data table which you will make over there. For example, I'm saying here that this is a major marking area where marks should be included. For example, he is saying that you are using quantity, you are using some symbol for it, you are using centimeter in the form of showing unit like that. I'm not writing centimeter in the form of length, I'm writing here unit. And then you are taking a reading, and you are also taking the processed quantity over there in the last processed quantity by using some relation depending upon how many times it is used, and you need only one like that. For example, I am adding here quantity is length, and which symbol you are using for your experiment. For example, I'm taking L, as length over there. I will say it is measured in centimeters. Reading is taken like 20, 25, 30, etc. That will not be processed. Then I am taking that time for 10 oscillations, time for 10 oscillations like that. Then what I'm saying, I'm taking the time t in seconds, and I'm getting some value like 16.8, 15.8 like that. 15.8 and etc. I'm recording the value. And for time period, I'm showing the symbol with the t over there, which I will say it will t divided by total number of oscillations, which I am taking over here, like 10 over there. And for calculating my time over there can be used. And there are some rules for data table. Heading must include both quantity. First of all, what I am saying, heading must should include the quantity which should be used. It should have the quantity with unit, not with just means quantity like VV, not just V like voltage. I am counting down and I'm saying voltage over with unit V should be being taken. Mostly you have observed in O levels exam table over there. After that, readings should show the consistent decimal places over there. The readings should show consistent decimal places over there. Decimal places. I'm also saying again and again over there that record at least 5 or 6 readings for full marks. It is a compulsory point over here, which I am saying at least get 5 to 6 readings for your full marks. Over there. I'm also adding here, for example, you are taking the pendulum or you are taking the voltage or something else, like then you should have to go for processed, like which I said in the last, like processed quantity over there. For example, he is saying that the processed quantities should be calculated correctly by using calculator over there. Processed quantities should be being taken, should be being taken are measured accurately. Like you have not calculated here t square like that, or here you took the time period over there. You can take reciprocal of voltage for getting the voltage value using the current or resistance over there. So always use the 3 significant figures. Always use 3 significant figure values at least to get your full marks over there. This is an important tip that your answer should be at least 3 significant figures over there. After that, this section in which the table is formed over there, I'm saying the next one is plotting the graph, which is having a 6 to 8 marks are given for plotting the graph properly over there. So rules for perfect graph, which I am stating over here. First of all, I will say for plotting a graph, plotting of graph. First of all, just observe your values and label the axis like quantity with unit. Label the axis with their respective quantities, quantity plus unit also. Mostly the students write there the quantity, but they don't mention the unit over there. Always try to mention that. For example, you have taken current, then write also ampere. And when you are going for voltage as V, also mention volt over there. And there should be a suitable scale on the graph and use at least half of the page. Okay, use at least half of page for reasonable scale over there. Half of page for reasonable scale over there. And then I will also say here, when you have plotted the points with sharp pencil dot and small circles over there. Like this is your graph and you have plotted with pencil, and also a small circle should be drawn over there. Then take a very narrow pencil and draw the best fit line, which should be a straight or smooth curve, not join the dots over there. So I will say here, after plotting these graphs, means draw a best fit line or smooth curve. That should not be showing any bending over there. That should be a smooth curve with a free hand if it is curve, and straight line if it is a linear relation. In the start, if I show you here, I mentioned that for this question, he will take only two types of relationships, that is linear relationship for straight line graph over there, and for this one, it can be taken any smooth curve, that can be taken in the form of some curve like this or curve like this. So these curves should be being taken by a free hand, should not be taken by like in the form of bends too much over there. After that, I will say here that when you have calculated and drawn the graph over there, any anomalous points should be circled and ignored for the best fit line. Say, for example, you have taken some point here also. So these are your straight line points. Then you can say this one is anomalous point and just ignore it over there. For example, uh, when you are saying, for example, I say if the question is says like v is equal to I r over there, then I can simply say here for this whole relationship, when v is equal to I r, then gradient will give you the resistance over there. Gradient will give you between v and I. For example, you have taken v here and I here, then you will have to take the reciprocal of the gradient. If your v is here and I is here, then you can say simply gradient is going to be taken the resistance to be calculated by using this relationship for Ohm's law over there, and intercept will be 0 as it is going to pass through origin. Then remember that intercept will equal to 0 if graph is passing through the 0 point over there. After that, you will have to go for the calculation of gradient and their intercepts over there. Gradient and intercepts. For this whole purpose, I will say here, when gradient and intercepts are being taken, then we can say then use a large triangle that covers more than half of the graph to find the gradient over there. Means when this one is being taken, like this is a graph, try to take at least half of the graph. Okay, and then we know the basic formula for the gradient is gradient. For example, I am taking m as a gradient over there, then I am saying it should be being taken as y2 minus y1 by x2 minus x1, where x1 y1 and x2 y2 are the 2 points which are being taken. This is x2 y2 over there, and this one is x1 comma y1 over there, can be taken into account over there. And for intercept, to find the intercept, then I will say use the relation y is equal to mx plus c over there. Then make this c as a subject, then c will equal to y minus mx. Then use this relationship or this equation for calculation of intercept over there. Finally, use the gradient and intercept to the given equation to calculate the constants over there. For example, if you have plotted a graph for pendulum case between t square and L over there, and you want to make the relationship over there, then if you are going to plot this graph, then I'm saying, for example, you have plotted the graph and you find the relationship according to the formula t square is equal to 4 pi square over g into L. Then this one will be your gradient, because this will be your y-axis, this will be your x-axis. And if you take the relationship between both of them, then you can say your gradient will equal to be helpful to measure the gravitational acceleration over there, like 4 pi square over G is equal to gradient, then if he is asking to you calculate G for it, then you remember that 4 pi square divided by G divided by gradient can be used for the calculation of gravitational acceleration over there. After that, when you have calculated the uh, uh, plotting graph, gradient, intercepts, then you will have to go for evaluation and how sources of error can happen and what improvements can be provided over there. You will be often get 4 to 6 marks for identifying the realistic experiment errors and improvements. So evaluation is required for 4 to 6 marks over there. Then common sources of errors can be parallax error, means you have not taken properly by looking at the proper meniscus over there. Parallax errors can be there. There can be zero error that can be due to faulty operators, zero errors over there. And there can also be air resistance or friction affecting the motion over there. Air resistance or friction, which is affecting the motion over there. And I can also say here that when air resistance is available and temperature changes will also be available over there for affecting the resistance of wire, like that. If you are provided with temperature changes affect the calculations, affect the resistance over there. And I can also say here that fluctuating reading on meters or stopwatch reaction time, there can be a random errors will be available. For improvement, all of these errors over there, we should being taken with use digital meters for precision, use digital meters for precision exactly over there. And use the clamp stand to reduce the vibrations over there. Reduce or use the clamp stand for use the clamp stand for reducing the vibrations over there. And also, I will add one more thing over here, that use the when you are looking that there is still error available, then go and get repeat the readings and take average or take mean value over there. Then it will be much more supportive for you to do this. Don't write vague things like take more care. That is not be going to be credited according to your marks over there. Okay, like take more care, take hold it, like where we say take care, or it means emotions are not should be avoided. Like we should go with full concentration, we should look towards with too much keen over there is not being required and will not be awarded over there. That is your question number one, in which I said, first of all, you will have to understand, then go for the relationship, plot the graph, get the values, and plot the graph and draw the best fit line, go for gradient, intercepts, and then go for evaluation of this whole experiment for question number one over there. Then we will have to move question number two, that is a short experiment, we can say our planning task over there. This is a planning task, or I can say that is a short experiment also. Short experiment over there. For this whole purpose, I will say this section tests your ability to think like an experimental physicist, and you might be asked to plan an experiment to measure. You can be asked as plan an experiment to measure a constant, to measure constant. Like I can give example over here like resistivity or refractive index also can be given. Again, can be asked that how you can measure. Describe a method to ensure the accuracy. Describe the method to show accuracy. Over there can be taken into account. Identify control, independent and dependent variables. We should have to go for identification of control, independent or dependent variables over there. And if we go for this type of question, then for example, I have given the example over here that it can ask for measurement of resistivity. Then I will say that for example, he is asking over there that describe an experiment to determine the resistivity of a wire. Then your step-by-step answer can be taken into account. For example, you will say how you will go like at number one, I'm writing here like measure the length of the wire using ruler. Measure length of wire using a ruler. After that, I can say here at number two, I will say measure the diameter using vernier caliper or screw gauge over there. Measure the diameter using vernier calipers or screw gauge over there. And you can also add here that for as we know that according to resistivity R is equal to rho L over A. You have calculated L, A is required, then use the formula there as pi d square by 4 for getting the cross-sectional area over there. And for if you want to measure the resistance, then use get the values of voltage using voltmeter and current using ammeter, and then plot the graph between both of them and take the gradient and get the resistance over there, and then use this formula rho is equal to R A over L, because all of three values have been calculated over there and it can be used for the measurement of resistivity. And here he can ask you about precautions and improvements over there like that. Then for this section, I'm writing over here like avoid heating means use low current, use low current over there so that heating cannot happen over there, or clamp the wire straight to avoid kinks. What I'm saying here, clamp the wire straight, clamp the wire straight and avoid kinks. And it can also be there, avoid kinks over there. I am just writing according to my above example over there. And I'm also saying there, measure the diameter, measure the diameter in several places, measure the diameter of wire at several places over there. And we can also say if we go towards the marking summary, then I'm just introducing you with the marking summary that first of all, which he will go for the corrections, he will is going towards how he is avoiding you. Mostly students miss that, how they are recording means correct units plus there should be correct decimals, consistent data, there should be decimals properly being taken, and consistent data. data over there should be available, and for this one 6 to 8 marks are awarded over there. Then there is graph. For this purpose, remember that scales, labels, and line of best fit, all three can be taken like scales, like labels, and line of best fit, and line of best fit is being recorded or awarded over there to have again 6 to 8 marks over there. And on the other end, then you are going towards the gradient and intercepts used. Then I will say that is named as analysis, in which he is going to note down about gradient and intercepts over there. So this is also being taken for 4 to 6 marks over there, will be important for it. And then you are going towards evaluation, like how errors and improvements can be done. And so for this purpose, he is again going for 4 to 6 marks again. And at the end, planning, that is a clear method that the variable safety over there is being taken from 6 to 8 marks. The last section, in which he is saying what are the drawbacks and what are the improvements that are being taken from 6 to 8 marks over there. So this is the way how your 40 marks are going to be taken over there. Here I am also going to add some general examiner advice over there, that always write the units everywhere. Keep your working neat and structured. Graph must occupy at least half of the grid. And when in doubt, record more data, not less. Never round the intermediate values too early over there. I'm just telling about according to examiner advice over there. If the question asks for a comment on your result, then mention uh, linear pattern, scatter pattern, or intercept over there. When he is asking like for linear pattern, then confirm relationship, scatter pattern, then random errors present. If it is going towards intercept, then it may indicate the systematic error over there. And if I talk about the general topics which you will have to be taken derived for common practical topics over there, then the first one will be simple pendulum, simple pendulum over there, in which he will say here find G by using by plotting the graph T square versus L. This will be your first man experiment according to its topics over there. And you will use the key formula for it. T is equal to 2 pi under root L over G there. This is your first man section experiment. Second one can be Hooke's law. Second one can be there as Hooke's law. Hooke's law. And Hooke's law states, regarding to this, when find the spring constant, when to find spring constant K over there by using the formula F is equal to Kx over there. I am also adding the number 3 over there, which is related to Ohm's law. Ohm's law over there, which we know that it is like to find resistance R, he can also go, and he can also find the proportionality of voltage and current over there should be being taken. And for this one, you know the famous formula of Ohm's law, V is equal to IR. For number 4, I will say the main important is related to resistivity. Resistivity over there. And for resistivity purpose, then I will say we will have to go for plotting plot VI curve, and no proper formula is available over there. And find the resistivity of wire by using the formula rho is equal to RA over L. That can be the formula over there. And for diode, you will have to go for VI curve. And heating and expansion, if he can ask for in another experiment, that can be heating plus expansion. For that purpose, like relate to resistance temperature expansion, then I will say resistance is directly proportional to temperature over there. These are the common practical topics in A's level physics of paper 3 over there. And here I will say, if I, in the last final tips before the exam, which I should give to you, that revise the graph interpretation and data analysis, practice tabulation data with correct units over there, memorize the common sources of errors and practical improvements, which is the 8 marks question over there. Get the familiar with the instruments, ammeter, voltmeter, micrometer, stopwatch, like that. Work clearly and label everything clearly. Most lost marks are for poor presentation, not bad physics, like that. And I will say that you should try to make more precise, and best of luck for your exams, which is going to happen. And I will again and again suggest you that try to more become more precise towards your measurements. Label the we can say label the for highly recommended values over there. And mostly he will going to ask to you to plot the graph properly over there, and get the best fit line, mention the anomalous points over there. At the end, I will say best of luck over there. Kindly subscribe my channel, and thank you for watching video. Subscribe the channel over there. Thank you so much for today.